Well, let's start by first talking about how this crankshaft balancer works. It has these two stanchions where there's V-blocks up in the top and a V-block here. This is where the crankshaft is going to sit, and it's going to spin on these blocks. On the right end of this piece is an optical encoder, and this is going to tell the computer where it is position-wise so that it can tell you where to correct. And the way this system works, let's see which one, yeah, this one will work here. So we have this lower section here that's bolted down to the base frame of the machine. And then there's these two vertical pieces which are just steel material, about probably 3/16 of an inch thick. And what these create is a spring. So as that crankshaft imbalance actually operates, it'll actually cause this upper section to shake. These are going to act as a flexure. And in the back here, there is a piezoelectric pressure sensor that is being pressed against either the top or the bottom, I don't remember which, so that as this guy flexes towards the back and towards the front, this pressure sensor is able to measure the amplitude of that flexing. And this one over here on the left does exactly the same. So the computer is not only looking at the amplitude, but it's looking at the position degrees-wise and comparing it all, or correlating everything down to degrees, amplitude, and to determine the amount of correction necessary. All right, so let me grab the crank and we'll stand it up there. I'm going to put the front of the crankshaft over towards the optical encoder. I'm going to probably need to adjust the distance between these two. So let me first throw it up here and see where it is. All right, so it looks like I need to move this left one over that way about 2 to 3 inches. Back up. I need to move this left one back just a little bit more. I'm going to flip this block over. There we go. I want to make sure that it's going to spin and not rub on the vertical pieces there. Now I'm going to take this encoder, and on the end of it, it's got a magnet, and we're just going to stick it to the end of the crankshaft. Now this encoder is not only looking at the position, but it's going to be controlling the left and right position of this crankshaft. So I need to make sure that my little double cardan U-joint is going straight at the crankshaft and playing with it too. All right, so we see everything's spinning well. Now in the bottom of this base there's an AC motor, and it's going to operate this flat belt, and it's actually what's going to be the driving force for the crankshaft to get it to spin, because we're going to attach the bob weights and then spin the crankshaft. Then the flexures are going to move, and that's going to get measured, and then the position of the imbalance is then going to be correlated with the encoder, and hopefully we'll end up with a nice balanced crankshaft when we're done. All right, there we go. So let me go grab the bob weights and we'll start installing them. Now before I install the bob weights, what I need to do is get this first rod journal to the very top. Let me zoom in on that. Focus a little bit. We need to get this rod journal to the very top of its position. And in most cases, the keyway for the timing gear and for the oil pump is going to be positioned with this guy at our top dead center. So I'm going to take this digital level. I'm going to rotate the crankshaft until I get to 0 degrees. So we're right there. Now over on the screen, all right, so this is the screen for the balancing system that we use here. The machine was built by T&S Machines in Gainesville, and the software was built by Turner Technologies, or their crankbalancer.com, I believe, or crankbalance. So this is the interface for the system, and the things that we need to set up are a correction radius, and that's what's the diameter of the counterweights from center out. What's their radius? We also need to know the distance from one vertical support to the next vertical support. It's kind of like balancing a tire. You need to tell the machine the width of the wheel, the diameter of the wheel, and it'll determine offsets. The other thing it needs to know is the offset. So how far from this vertical support in does it have, is the first counterweight? On ours it's going to be about 1 inch, maybe a little bit less, because they're right there at that first and last main bearing. Now this system does calculate bob weights, and you can see actually I've plugged them all into here. We got the same rod total, and it came out to the exact same numbers that are calculated over at the table. Now with the crankshaft at 0, I need to zero the position on the balancer, so we're just going to hit 0 shaft, and that just puts that at 0. And then we get into installing the bob weights. Now, because we're starting on number 1, we're going to go ahead and install the first bob weight. Now these bob weights are only numbered for repeatability. Because they're all the same weight, they can go in any position and have little or no effect on what happens. But if I need to take this bob weight off of the crankshaft and put it back on to make it the most repeatable possible, it's best to put the bob weights back in those positions, because they have a certain amount of moment, meaning these weights right here might be at a different distance from center than these over here, and just trying to keep those things all the same and repeatable makes life easier for the crank balancer. Now when I install this bob weight, I also want to make sure that the top of this weight is level. So I take the same level and set it 0. I'm going to go ahead and level it out to where it's at 0 degrees, and keep overshooting it. There we go. And then I'm going to tighten it down and then move to the next one. All right, we're at 0 degrees. I need to go to the next rod journal. And because this is a V8, we have rod journals located every 90 degrees. So I'm going to rotate this crankshaft 90 degrees. And you can see it's going to change, and then when it gets to 90, the number will actually turn red. And back up, and then we're ready to install the next counterweight. As I go through this process, I'm going to go to, I've already gone to 90 degrees, the next one is going to be 180, and then the last position is going to be 270. I'm on my 3rd journal, so I'm going to take the bob weight number 3. I also want to make sure that I position the bob weight front to back at some position that is repeatable. Some people say that if you put them all forward or all backwards, it changes the imbalance. I haven't noticed anything. I just put them in a position where I can repeat it. Sometimes I'll take an Allen wrench and put it down in between and say it's a 13 millimeter or a 1/2 inch Allen wrench. I can make that very repeatable and make them all the same. So there's number 3. We're going to rotate it to 180. There we are, we're at 180, so we're going to install the bob weight onto the last one here, which is number 4. I'm going to check its level. Right at 0. Tighten down the nuts, and then the last position is going to be 270. I'm watching the screen as I turn it. And there we are at 270, and we're going to put on the second, or the number 2 bob weight. Which should actually be the last bob weight, huh? Got them just snug, put on the level, rotate it, and we're there. What I like to do is just go through them one more time from one end to the other, making sure that they're all tight. You're not supposed to rotate them by the bob weight stud, so I'll try not to do that. There we go, because if you rotate it by the stud, you run the risk of actually rotating the bob weight on the journal. And we're ready to run our first spin to see where it's at. I just have to lubricate the journals on the bearing blocks. I did it again. I'm turning it by the bob weight. Shouldn't do that. Okay, so we'll come back and we'll run our first spin. Here we go for our first spin. My first spin, I'm going to run it low at about 300 to 400 RPM. Just in case the imbalance is really crazy. Because I don't want the crankshaft to bounce off the balancer. Okay, so we're sitting at about 400. Push the button on the screen. Then push it again. Okay, and we'll turn off the motor, let it spin down, and we'll take a look at the screen. There we go, we're at the screen. Now notice that these full circles right here, that's just indicating that our correction could happen in any position. But the problem is, to do a correction, we have to have something there. But the bob weight or the counterweights on the crankshaft don't go all the way around. So what I'm going to do is set up the zones. So we set up the zones, and I'm going to set up the right hand or the front, and then the left, which is the rear. I'm going to set up begin. I'm going to have it rotate around and then push end. I'm going to do the back one, begin. And what it's showing in the red is open space. The blue section is where the counterweight's at. So what this indicated, let me go back to the previous thing. I'll just reset this. There you go. So what it's telling me right now is that I have 38.7 grams of imbalance on the rear and 14.1 grams of imbalance on the front. So it's telling me to drill a hole, and let me see what the drill setup is at. Okay, it's telling me to drill a 1/2 inch hole, 0.949 inches deep at 341 degrees. And what that means is as I rotate this crank around, when that goes all the way to the top and turns green, right at the very top is where it wants me to drill. But there's a problem. Let me pivot over. I know it's a little dark right there. Let me zoom in. I don't have anything to drill into. The counterweight is down here. If I have this in that position, it's telling me to drill and take material out right here. The problem is there's nothing to take material from. I can grind on this here, but the problem is the closer you get to the center, the less material removed, the less that same volume of material removed will have effect on the overall imbalance. So what it's going to have me do is do something to this side to increase its mass. Let me set up the zones again. Oh, I'm going to do this. So what I was doing is on the screen, I had it right here because it's going in that direction, begin, and then I push the other button. When this is ending, right there, end. And I do the same thing for the back. It's beginning now. Oh crud, I messed up. Push the wrong button. There you go. Begin and end. And then the back one is begin. And then the end of the counterweight is right there, end. All right, cool. So let's go back over to the screen. Okay, exit out of the zones. So what it's wanting me to do is install heavy metal. Now this heavy metal is going to be tungsten. Because tungsten is actually a very dense metal, whatever volume of material that I remove of the crankshaft, I press a piece of tungsten in its place, and that tungsten, because it's heavier, will add weight to that section of the crankshaft. And it's wanting me to add weight to pretty much, well, I'd say at the third position on the thirds position, so a third of the way in on that counterweight, which puts me right at a very small divot. I don't have a big hole that I can fill. And then it wants a piece of tungsten at that position there. However, this one I think I can get because I have a deep hole there. I've got a hole that's probably 600 thousandths of an inch deep, right at that position. So what I'm first going to do is fill this hole. Well, it's a hole like this radially. I'm going to fill it with weld, use a MIG welder and fill it in. And then I'm going to rebalance it to see what happens to this weight. On this end over here, because it's 16.9 grams, I do have a couple divots that I can fill. So instead of having heavy metal installed, because heavy metal is, I wouldn't say it's not expensive, it is an extra expense. The customer does have to pay for this on top of a regular balance charge, but what I have is a selection of heavy metal slugs, and these are just pure tungsten. Okay, they've got some mass to them. And I actually drill a hole in the crankshaft, I press this in place, and I weld up one side to hold it into position. And that's a piece of heavy metal. Now they do make different diameters of heavy metal. This is a 1 inch, 1 inch by 1 inch long, so 1 inch diameter. And then I have a smaller one here that is a 5/8 of an inch by 1 inch long. So there's a smaller one there. And that's just another piece of tungsten. And these are things that will add to the cost of the balance. Now, by replacing the material that was removed from the factory, that's a perfectly legitimate method of fixing imbalance. So let's go freehand here. So like I said, I'll try and get that in focus for you. Like I was saying, let me go to the back here. This hole right here, that hole right there, is where it wanted a piece of heavy metal installed. And the way it gets installed is that we drill and ream a hole axially through the counterweight, and then we press that metal in through the end of the crankshaft. And that's going to add the weight to the crank. In this case here, because I have about a 500 thousandths deep hole, what I'm going to do first is use a MIG welder to fill this hole in to flush, and then we'll run a rebalance on it and see what happens to the imbalance reported by the machine. On this end of the crankshaft, we have 16.9 grams, and it's asking for it to go in right up here. So we have a hole, it's got a certain depth to it there. I'd say it's probably 250 thousandths. I'm going to go ahead and fill this in. Now I do have two adjacents, kind of like splitting wheel weights. You can actually add the material. If you go an equal number of degrees this way and this way, you'll have to add more than you would in this single position. So what I'm going to do on this one is fill this hole, because it's not very deep. I'm then going to fill this one, and then partially fill this one to see what happens to the imbalance. Okay. All right, so that's balancing. Now when we get into balance correction, we have the drilling head here that we then use to drill out the crankshaft if we have to do any corrections to remove a material. So, and that's it there. And then this is the whole setup. So we've got our balancing computer here, the actual balancer base, the verticals, the stanchions, the flexures like I was saying, and then of course the drilling head here that slides back and forth on the machine. And then over there on the wall we have 5 of this V6 ones, and then we have a 10th V8 one, which is actually used for V10s like Vipers, because they are 5 rod journals on those. So we'll make it a separate video doing the corrections and looking at the effect of the corrections. So until then, we'll see you later. Test, test. Here's the story. The camera battery died and I couldn't get the test spins after doing some weight corrections. So here we are at the end. I've got the crankshaft mounted up in my lathe to do some final polishing on the journals, and all the corrections are done. So the crankshaft is in the same orientation as it was in the balancing machine. And I think we started out with 36 grams on this side and 19 on this side. I might be wrong on that, just have to go back and look. And I talked about filling in the holes that were drilled from the factory. And I filled in all but one factory hole here. And then on the other end of the crankshaft, I left the very deep hole, because one, it's hard to drill to the bottom, I mean not drill, but weld to the bottom of the hole. And 2, it would have been a lot of material to add in. And not that I had to fill it in entirely, but I didn't need to. So I filled in, there were 3 holes over here, And then I did a partial fill on this one because it was only about 300,000 to 400 thousandths deep. So after I made these counterweights as heavy as possible with filling everything in, that then went from wanting to remove material on the rod journal side to needing to remove material from the counterweight side. So to remove some of the material, I added an extra drill point there, and I've got another drill point over here. So those two drill points were to remove material, and what that was doing was moving the imbalance over here to this section, because crankshafts are not, especially modern ones, this isn't one continuous radius around here. It's actually been cut down at the factory. So what I did was just slowly start grinding this material away with a angle grinder until I got it to within, well, under a gram. So I have less than a gram imbalance on each end of it. And with that, I was doing the final polishing over my welds to make sure that there's nothing sticking out. And then that's the end of the job. So remove the bob weights, put them back on the wall, and it's ready for the next one. And I do apologize about not getting the check balance in the very end. I wasn't near, I didn't have my battery charger for my camera. And that's just the way the cookie crumbles. But what I'll do in another video, because I do have another crankshaft to do, instead of doing all the prep stuff, because this one did include a considerable amount of conversation about bob weights and rotating and reciprocating weights, that one will just be setting up the bob weights, balancing, and then balance corrections. So other than that, this thing just needs to get polished up and it's ready to go to the customer. One thing I will note is that I did do a little bit of polishing out here just to see what the effect would be, because the radius on these journals is less than the radius on this outer diameter here. So I did some polishing just to see what I could do, see what effect I would have on the balance by removing some material here, because they have factory pads, or pads from the factory. You won't be able to see it on this one here, but there's a pad here from the factory that they leave in for manufacturing, for locating. And I just kind of took the corner off just to see about how much, and it was a considerable, it seemed like a considerable amount of material, and it only really affected the imbalance by 1 to 2 grams, and that was about it. So it was 1 gram on this end and 2 grams over here, and it was you know, a considerable amount of grinding. And grinding near journals, before I do the grinding, I do wrap them with some tape just to make sure I don't hit the journals and then damage the journal. So other than that, I guess this is the end, and we'll see you next time.